This lesson is about probability and two-way tables. For the soccer banquet, the players and their family members selected their favorite main dish and a side dish. Of the 39 people who chose chicken as the main dish, 18 wanted potatoes. And there's more information here, but the bottom line is going to be which two-way table correctly displays this data. So every time they give me some information, I'm going to hunt for it on the table, and if the table doesn't match, I'm going to throw it out. So 39 people who chose chicken as the main dish, 18 wanted potatoes. Okay, so here I see of the 39 people who chose chicken as the main dish, so far so good, 18 wanted potatoes. Oh, look, it should have been 21. That tells me that this table is wrong, so I'm going to throw it out. So let me stick with that data. 39 people chose chicken as the main dish. All right, so again, we're looking good with the 39 people. And of those, 18 wanted potatoes. And there I've got the 18 that wanted potatoes. So far this table is working for me. Of the 32 people who chose rice as a side dish, okay, let's see. 32 people, so we have rice as a side dish. 32 people total chose rice as a side dish. Still sounding good. 6 chose fish as the main dish. So of these 32 people, 6 chose fish as the main dish. So this one is looking like the answer so far. A total of 8 people chose a vegetarian meal with potatoes. Okay, vegetarian meal. Okay, these people chose a vegetarian meal. These people chose potatoes. Okay, so 8 people chose a vegetarian meal with potatoes. So that's great. And a total of 10 people chose fish as their main dish. Okay, here's fish, and here's the total. 10 people chose fish as their main dish. So this second table matches everything they just said, so it must be the answer. And yes, it is. If you look at the other tables, it would have not matched one or more of those pieces of information. A fast food restaurant kept information about the drinks that were ordered, along with the different sized kids' meals as shown in the table. So we've got this table, regular kids' meal, large kids' meal, and in each case, they got either milk or juice or soda, and we have the totals shown here. First of all, let's fill in the missing numbers. So in the milk column, we have a total of 71, but we see for the regular kids meal, that was 55. So we should be able to subtract to find the missing number. So right here, what I'm doing is 71 minus 55. And that's going to give me how many milks went with the large kids meal. So 71 minus 55, that means this is 16. Similarly, to get this number here, we're going to do 60 minus 22. So that's going to be 38. All right, now these two different kinds of the sodas with the different size meals should total up to the final number. So we're just going to do 63 plus 86, and that is 149. And one more time, for this number right here, I'm going to do 280 minus 156, because these two should add up to the total of 280. So 280 minus 156, and I have 124. So, which statements are true? Check all that apply. Milk was requested for 16 of the large-sized meals. All right, milk, large-sized meal, 16. That's true. Soda was requested for 280 of the kids' meals. Soda, wait, for the, oh, okay, for the kids' meal order. So that means all together, because I was looking for regular or large, but they're looking for the total. So, well, no, it's not 280. 280 is the total number of kids' meals, regular and large. Soda is right here. All right, it's 149 were soda. So not 280. Okay, a juice box was requested for 82 of the regular sized meal orders. Okay, regular sized meal order, and we're talking about juice box, so we're talking about this number right here. 82? No, it should be 38. Okay, what else? Let me get my highlighter ready. 63 of the orders of soda came with a regular sized meal. So we're talking about soda and a regular sized meal. So soda, regular sized meal, that should be 63. So that matches. A total of 124 large-size meals were ordered. So we're talking about large-size meals, and we're talking about the total, which would be over here. That's 124. It says 124 right there, so that's a match. So these three should be the answers. And there you go. Information about the recycling drive at school is shown in the table. Let A be the event that the item pulled out of the recycle bin is a plastic bottle, and let B be the event that a 10th grader recycled that item. All right, so let's see. A is plastic bottle. And B is 10th grader. Now, which statement is true about whether A and B are independent events? So look, here's something that you have to memorize about independent events. Write this down. Okay, A and B are independent events if the probability of A given condition B is the same thing as the probability of A without any conditions at all. In other words, the condition B is not really changing the probability. If I took condition B and I scribbled it out, then it would give me the probability of A. So in other words, the fact that condition B is thrown in there is not actually changing the probability. That's how you know that events are independent. So basically memorize this fact. So we need to calculate each of these things and see if they're equal. If they're equal, then we'll say that these events are independent. If they're not equal, then they are not independent. So let's calculate the probability of A given B. Okay, now when we say given B, let me get my highlighter warmed up here. When we say given B, in this case it means given that we're talking about a 10th grader. Okay, so that makes this our universe for the rest of this problem. Okay, as soon as you say given B, that means whatever B is, that's all that matters. Everything else is going to get crossed out. Okay, so just to make it easier for you to focus, I'm going to blacken out the rest of this. Okay, this is all gone. Okay, I don't even think we need this down here. Alright, this is the universe because we're given B, we're given that is a 10th grader doing the recycling. Now, in this universe where we're given B, what is the probability of A? What's the probability of pulling a plastic bottle? Okay, well, that probability is target over total. Let me erase this so I have space up here. So probability is always target over total. So if I'm talking about plastic bottles, then plastic bottles are the target, so that would be 40. Now when we talk about the total, notice I'm using the 150, alright, not whatever this was that I just blacked out. Okay, because we're given B. We're given that we're dealing with a 10th grader. So when they say total, target over total, it's just the total of 10th graders. That's all that matters. So 40 out of 150. Let's see, what does that reduce down to be? All right, 40 out of 150. Okay, that's 26.266 repeating, 4/15. Okay, so this is 4/15. Okay, now let's calculate the probability of A without any conditions and see if it is also 4/15. If it is, then they're independent. If it's different, then they are not independent. Okay, so this side has no conditions. So I'm going to take away all that blackness. So I just want the probability of A now. So the probability of A, that's the probability of choosing a plastic bottle. That's target over total. Okay, so we're dealing with plastic bottles out of the total. But this time we're not just stuck with only 10th graders. So plastic bottles, there are 135 plastic bottles. Okay, so that's when I say target over total, it'll be 135 plastic bottles out of a total of 400 bottles. Well, 400 items. You know, some of them are cans. Okay, so this is going to be what it is. Without any conditions, without the 10th grader condition, it's 135 plastic bottles out of a total of 400 items. So let's see if this turns out to be 4/15. Okay, 135 out of 400. Okay, that is not 4/15. Alright, that's 27 out of 80. It's not approximate. Alright, but the point is, these are not the same. These are not equal. So, as I look at the statements to decide which one is true, I'm looking for one that says the probability of A given B is not equal to the probability of A by itself. Or they could have done it the other way around. They could have started with the probability of B given A. Alright, in that case we'd be looking for that to equal the probability of B. Alright, because it's all about taking the condition, you know, the extra information, and you should be able to throw it out. All right, so it shouldn't matter. So the probability of B given A should be the same thing as the probability of B without being given A. But let's look for the blue one first. Okay, and you can bet that that would also be not equal to. All right, so first of all, the first couple ones say that they are independent. Well, we disagree with both of those. All right, they were different, so they are not independent. Okay, so the probability of A given B did not equal the probability of A. And that's this one right here. It's exactly what we have. Okay, so that should be your answer. And there you go. Okay, for this problem, we're supposed to decide which pair of events are independent. So remember, if two events are independent, then the probability of the first event given the second event, that should equal the probability of the first event all by itself. So if this is true, then they're independent. If it's not true, then they're not independent. So let's do both of these. So let's calculate the probability of A all by itself without any conditions. Okay, let's see. So the probability of A. So that's target over total. So if we're talking about A, okay, so these are the A's, and this is the total. So the probability of A should be 30 out of 100. Okay, we'll simplify that in a moment. So that's just A without any conditions. Now let's do the other side, the probability of A given X. Now when you say given X, that's telling you what the universe is. X is the universe. So that means this is the universe. Nothing else matters anymore. Okay, because we're given X. That means all the rest of this goes away. And I like to emphasize that by blacking it out. All right, just so you don't get distracted by these numbers over here. All right, that's what it means when they say given X. It means only X now. So now, in this universe, what's the probability of A? Well, in this smaller universe, the probability of A, we're still doing target over total, but now the A's are only 15 in this smaller universe. And the total in this smaller universe is only 50. So the question is this the same ratio that we got before we blacked out part of the universe? And let's see. Well, 15 over 50, that's 3/10. And of course, 30 over 100, you can see right now that that is also 3/10. So these are equal. That means A and X are independent. Okay, so I know already I got lucky and the very first one happened to be the correct answer. Now just to show the difference, let's pick a different one and show that they would not be equal. I'm not going to do all four. But let's do one more and show that this next one is not true. All right, if A and Y are independent, then the probability of A given Y should equal the probability of A without any extra conditions. So let's calculate both of these. Well, the probability of A, we had already done that on the previous problem, but just looking at it super fast. Probability of A, here's A, here's the total. So target over total For A, there's 30 A's out of a total of 100. Okay, now the probability of A given Y. When you're given something, this is your universe. Okay, so given Y, that means Y is the universe. So I'm going to throw out the rest of this. Only Y now. Y becomes the whole universe. Okay, a universe of Y. So in a universe of Y, where Y is given, now we ask ourselves, what's the probability for A? That's not a marker. So target over total. These are the A's in this smaller universe, and this is the total. So 5 out of 28. So the question is this the same thing as 30 out of 100? Well, 5 out of 28, that doesn't reduce. So this is just going to stay 5 out of 28. And this reduces down to 3 over 10. Those are not equal, so these are not independent. And that's the same type of thing that would have happened for the rest of these. This two-way table shows the number of houses on the market and in the Castillo's price range. Okay, so we've got 1 bathroom, 2 bathrooms, 3 bathrooms. So we have number of bathrooms along this side, and along this side we have the number of bedrooms. And we can see how many houses fall into each one of those categories. So for example, this spot right here would represent the number of houses that have 3 bathrooms and 3 bedrooms. Okay, so I think we all understand the chart now. Now, what is the probability that a randomly selected house with 2 bathrooms has 3 bedrooms? Okay, so they're giving us some information right up front. They're saying with 2 bathrooms. Okay, so as soon as they say with 2 bathrooms, we can zone in, we can focus in on this row right here. All right, so a randomly selected house with 2 bathrooms, boom. Okay, that means, just so we don't get distracted, let's black out the rest of this. For the rest of this question, let's pretend that there are no 1 bathroom houses and there are no 3 bathroom houses. Okay, so these totals down here will now be meaningless. Alright, so we're in a universe with 2 bathrooms. So, given that we're dealing with 2 bathrooms, what's the probability of randomly selecting a house that has 3 bedrooms? So, now that we're back to talking about probability, we're thinking about target over total. That's the way I like to think about it, target over total. Okay, we've already got this nailed down. So 3 bedrooms though, that's the target. Okay, so 3 bedrooms, I'm seeing that's 24, right? Okay, this is the 3-bedroom column. So we have 24 3-bedroom houses out of a total of 30. Target over total, 24 out of 30 in this smaller universe where we are only dealing with the 2-bedroom houses. Okay, not the ones we had to black out. Alright, so we'll turn this into a decimal and that should be our answer. So 24 out of 30. 0.8. Okay, so it should be this last one. And there you go. The two-way table shows the estimated number of students who will enroll in 3 area high schools next year. So we have our 3 area high schools broken down by grade. Apparently no freshmen here. Alright, now in decimal form, to the nearest tenth, that means 1 decimal place, what is the probability that a randomly selected Riverside High School student. All right, I'm emphasizing that before I even go any further is because this is something that we are given. All right, we have all this extra information, but no, given Riverside High School student. So that means this is going to be our universe. All right, our smaller universe. So we're going to, hold on, I like to start with yellow. We're going to focus in on Riverside High School students, okay, because this is our new universe. Okay, and just to extra emphasize it, I'm going to black out everything else. We're going to pretend like this high school doesn't exist, and this high school doesn't exist. And so therefore these totals won't be relevant. This is all that there is, all right, because we're given that information right at the beginning. Now, I'm sorry, what were they asking us again? What is the probability that a randomly selected student is in the 12th grade? So when we're doing probability, you know that we do target over total. Okay, now that we shrank the universe down to Riverside High School, our target is 12th graders, but that means 200 students. All right, 200 12th graders. And the total in this smaller universe is 500. So we're talking about 200 out of a total of 500. Okay, dividing both numbers by 100, that's 2/5, which as a decimal is going to be 0.4 or 40%. All right, let's check it out. Kabam. All right, let's do one more. Okay, the two-way table shows the medal count for the top performing countries in the 2012 Summer Olympics. So let's see, gold, silver, bronze, and we've got some countries. All right, and we have the number of medals for each country. So which statement is true? So let's just go through these one by one and find the one that is true. The probability that a randomly selected silver medal, I'm just going to pause right there like skirt, silver medal, okay? That is a universe shrinking statement, all right? This is some information that we are given. This is a smaller universe now. Okay, so we're going to focus in on the silver medal. All right, so I'm going to forget about the gold and the bronze, and these totals are no longer relevant. Okay, now, what were they asking us? The probability that a selected silver medal was awarded to Great Britain. Okay, now the probability that's awarded to Great Britain, now we can talk. So when we do probabilities, we're doing target over total. Okay, now in a world where we already know that we're talking about silver medals, the target is now Great Britain, all right, because that's what we're being asked about. So let's see, Great Britain, that's 17 out of a total of 99. So 17 out of 99, that's the probability that a randomly selected silver medal was awarded to Great Britain. And we got lucky. All right, the very first one is a match. That statement is true. Okay, so that is going to be the answer. All right, let's look at one more. I feel like I cheated because it just came out to be the right answer immediately. Let's look at one more and see how it's not the right answer. All right, the probability that a randomly selected medal won by Russia. Okay, so as soon as they say won by Russia, okay, that is a universe shrinking statement. Okay, so if we're talking about only won by Russia, then we can forget about China and the United States and Great Britain, and these totals won't matter anymore. Okay, the universe has shrunk to won by Russia. Now, what are they asking us for? Bronze medal. What's the probability that a bronze medal is won? Well, target over total. Okay, the target is bronze. That's 32. The total is 82 in this smaller won by Russia universe. So 32 out of 82. But here we have 32 out of 103. No, that's wrong. So that's why that wasn't it. And you'd find a similar problem with the other three choices. Alright guys, that was the last problem. I hope this video was helpful. Good luck on your quiz.